0 to 1. Upper limit z equal 1. Oh, sorry, 2. Sorry. I understand. Sorry. You're right. My mistake. Sorry. It's e to the minus 2. Sorry. Yeah, you're right. Then it's e to the minus 2. Let me write this one. So psi 1 is equal to 5 times 10 pi 1 minus e to the minus 2. Thank you. Okay, so now let's go to S2. Integral over S1. And this is, the top one S2. The bottom one is S3. Why did I put, yeah. S1 is the side one, S2, S3. So now let's go to integral of top one. So now let's integrate over S2. Okay, let's find the characteristic of S2. Z is constant. So dz is 0. Remember, we are talking about the area. So wherever you have dz, this is 0. And z is equal to 1. So your upper limit e to the minus 2, z to the minus 2, 1. You only have this one left. So you only have 10 rho e to the minus 2 because z is equal to 1. D rho d phi. Again, separate. For phi is from 0 to 2 pi d phi. For rho is from 0 to 1. 10 rho e to the minus 2 d rho. This is equal to e to the minus 2 and 10, they're all constant. So you have 10 e to the minus 2 d phi from 0 to 2 pi, it's 2 pi, multiplied by rho d rho, 1 half, rho squared from 0 to 1. So from here, psi 2, which is integral, okay, rho at the lower limit is 0, at the upper limit you get 1 half. 1 half cancels 2, so you get 10 pi e to the minus 2. Any question? I integrated over upper. What about integrating over lower? Notice that we have integral upper and the lower, integrating over the lower portion. Any questions so far? Okay. Now, let me erase this part. Next integral is kind of important. Okay, for the next integral, remember, again, for the next integral, z is 0. This is the area, right? What is your ds in this case? ds is equal to, because z is equal to 0. So it's rho d phi az. Okay, I'm writing ds for this part. Am I correct for ds? What is the ds for the upper area, upper cross section? For S2, when you want to write an increment here, increment, what is ds? Again, ds, what is changing around this area? Rho and phi, not z. So it's rho d phi az. This is S2. Now for S3, S3 is the lower one. This is part of the cylinder. I'm also, rho is changing, phi is changing, rho d phi az. My question to class. I'm writing surface increment for the upper surface and a surface increment for the lower surface. How do you know that it's upper surface, lower surface? I'm writing the same thing. One of them is the upper surface of the cylinder, the other one is the lower surface of the cylinder. How distinguishes the upper or separates upper from lower? How do you know when you look at this ds? Which one is upper, which one is lower? Let's assume that I don't say S1, S3. I just say that I'm giving you increment for upper and the lower. And it looks fine because notice that the normal vector is along the direction and any increment along Z is constant, so only rho and phi is changing. So I have rho, d, rho, d phi. But what's the difference between these two? How?
Was in the origin?
Sorry?
When one was in the origin? The
It doesn't matter. I mean, at this point, because there is no Z here, that's my question. This is a cylinder. One of them is the upper area, the other one is the lower area. I'm writing surface increment for the upper one. What is changing? Rho, phi, it's rho, d rho, d phi. What's the normal vector to the surface? AZ. What about the lower surface? For the lower surface, again, what is changing? Rho, d rho, d phi. What's the direction of normal vector to the lower surface? Negative AZ. Not AZ.
Solo Fanta.
For upper surface, I have plus AZ. For the lower surface, for ds, I have minus AZ. So here, when I'm writing my rho ds equation, the lower surface, let me write the whole thing. If I want to write A ds for the lower surface, okay, z is equal to 0, dz is equal to 0. So what is your ds in this case? It's rho, d rho, d phi minus az, because it's in the, you must always have, electromagnetic is all about directions. You must always have the direction in mind. So when I'm multiplying A, I erased it. When you multiply that A by this ds, what you get, you only get z component of A. And for z component of A, you get into 10. Again, z is equal to 0. So it's e to the minus 2 times 0. This is for always z component multiplied by z component, but your z component of ds has minus sign here. It's minus rho, d rho, d phi. Remember, we had this integrand before, but we had plus. Here we have minus because it's the lower area. Okay, so this is equal to e to the power 0 is 1. So here you get minus 10 out, integral from 0 to 2 pi d phi, integral from 0 to 1 rho d rho. This is equal to 10 minus 10 multiplied by 2 pi multiplied by 1/2. So it's equal to upper limit 1, because if you substitute 1/2 rho, so it's equal to minus 10. Any question? So this is your side 3. You have psi 1, psi 2, psi 3. Add them up. So back to original problem. Back to original problem. What's total flux of the vector through the complete cylinder? It's 10 pi times 1 minus e to the minus 2 plus 10 pi e to the minus 2, that's psi 2, and minus 10 pi psi 3. Psi 1 plus psi 2 plus psi 3. So this is equal to 10 pi minus 10 pi e to the minus 2 plus 10 pi e to the minus 2 minus 10 pi. This one cancels this one. The net flux through this complete cylinder is 0. Do you have any questions? Please practice on this problem. Surface is symmetrical, everything is symmetrical until you feel comfortable with the concept. It doesn't matter if I show you. Some students sometimes they say, oh, we didn't see too many examples. If I give you 100 examples, it doesn't resolve any problem. Until you fully focus on one problem and try to resolve all your questions, confusion based on that one problem, then you'll be okay. Okay, so this is the surface side of divergence theorem. You may say, okay, in order to find flux, which is very important part of electrical engineering, finding electric flux and later magnetic flux, it's too much work. Notice that in this case, I gave you a very simple surface. It's too much work. Finding psi 1, finding psi 2, finding psi 3 for each case, breaking surface into 3 parts, and performing integral for each part. Is there any way to avoid that? And the answer is yes, the shortcut is divergence theorem. In order to avoid, the answer is divergence theorem. This is the left side, this is the left side of the divergence theorem. What is on the right side of divergence theorem? Integral A ds equal to total flux equal to the integral over volume divergence A dV. This is a scalar integral, and you don't have to break anything. So here, rather than considering 3 surfaces like side surface and the lower surface and the upper surface, we consider the entire volume. But in order to do that, this is the right-hand side of the divergence theorem. Step 1, you have to find the divergence of A first. Okay, divergence, this is cylindrical coordinate. So you go and check the divergence formula for cylindrical coordinate. It's 1 over rho. It's 1 over rho d rho of rho A rho plus 1 over rho plus 1 over rho dA phi d phi plus dAz dz. Okay, what is A? A is equal to, I gave you A, just repeating, same A I gave you for the problem. Let me check. Yeah, A is equal to 10 e to the minus 2z rho A rho plus 10 e to the minus 2z az. Okay, so A phi is 0. There is no A phi. So let's apply the divergence. Divergence A is equal to, you're taking integral over rho, so these are like constant 10 e to the minus 2z, okay, multiplied by 1 over rho d rho. What do you put inside? Rho multiplied by A rho. A rho is 10 e to the minus 2z, which I pulled out. Let me put, this is correct, don't change it. I just want maybe some of you get confused. Let's do it this way. I just want to copy this forward. Okay, what is divergence? 1 over rho, d rho. Rho times A rho, what is A rho? 10 e to the minus 2z rho. Okay? dA phi, sorry, dA phi d phi, A phi is 0, this is 0, plus ddz az. Az is 10 e to the minus 2z. Don't put vector component, just component. Don't put vectors, just the component, A component. So this is equal
Yo
to.
decía,
Now,
Terequito, dice, no le he
10
dicho a nadie.
e to the
ya tenía
minus
todo.
2z is a constant. You pull it out. So 10 e to the minus 2z is a constant. You have d rho
En los
of
chorros,
rho
póngalo.
square
Ya ves.
plus taking derivative with respect to z. Hopefully you know how to take a derivative of exponential. It's minus 2 e to the minus 2z. So this is equal to taking derivative with respect to is 2
Para que la
rho.
rueda
So
casi todo el día.
you have 20
Porque como
e
va
to the
después del
minus
pueblo.
2z, taking derivative. Okay. If you take a derivative, you get 2 rho. So multiplied by rho minus 20, 2 times 10 minus 20, e to the minus 2z. So it's equal to 20 e to the minus 2z
Zona paintball, aquí está.
rho minus 1.
Zona paintball se llama.
This is a divergence.
Ajá.
Okay?
Mira. Pero ese es en el mero bosque, man. Así, man. Ese está vergón, man. Ese está
Any
vergón
question?
porque te escondes y todo el pedo.
Este es Navarra, el que te digo yo,
Any question? Oh, I made a mistake. By the way, actually, it's much easier than what I thought. My God.
Pero este es solo para paintball.
I made a mistake here. Error. Can anybody detect the error? Just to
Cuando venís del aeropuerto,
make sure that you're paying attention. It's a very obvious error.
llegás al paso del nivel del hermano Alejandro.
Did you leave out the 1 over row?
Exactly. Yeah. I forgot one over row here. Actually, this problem is super easy on this side. I forgot to put this one over row here. So that will cancel this row.
Son inflables.
No,
20 to the minus 2
bosque.
is equal to 2.
Sí, nosotros fuimos.
Ah, ya fuiste vos.
Remember?
Sí, yo.
Uh,
Antes de bajar
What is
a
psi
los chorros,
if you are using volume?
está arriba.
Divergence A,
Ah, pero
dv.
25 por persona.
Divergence A is 0, so you get 0.
25 por persona, dice.
Remember,
Pero
right hand side, we went through 3 integrals, we included 0. Left hand side, right hand side, you get 0.
60 nos daban a nosotros.
50
Any question here? But now the question here is,
por persona. Incluye
please write a note for yourself. It's not this problem. Suppose I don't get 0. Suppose I have what I had here before, let's say. So this is not, this problem is finished,
tarifa normal.
done. Okay, let me just show you how to perform the right hand side integral. So let's say let divergence A is equal to
El otro.
10 e to the minus 2z times rho. Let.
Porque mi hermano
Okay, this is a different problem. Use the same
ya
cylinder.
no me lo quiso vender. Y a Gerson me lo vendió.
Use the right side.
Que tuvimos un problema.
Integral of divergence theorem. Find flux. If you want to use divergence, you have to integrate over volume. Okay, so this is equal to, you put the divergence according to what it's given, 10 e to the minus 2z multiplied by rho. You put volume increment in cylindrical coordinate, it's rho, d rho, d phi, dz. It's a triple integral. You put all rows together, so you have 10
Una semana
rho, d rho, integral
No, entonces
rho
uno-
square, because you have a rho here times
Siete
rho
que
rho
vayamos,
square, d rho, from 0 to 1. What's the range for rho?
No,
0
siete.
to 1. Multiplied by.
porque
Put
mi
all phis
camioneta cabe en
together.
8.
0 to 2 pi, d phi. All z's
8
together.
por 15,
And by the
120.
way, you have a
Ahí
constant,
sí,
you can pull it out, I put it here, that's okay.
120.
e to the minus 2z
Por
dz,
ocho
what's the
personas.
range for z from 0 to 1? And then you integrate one by one and multiply. What is the integral? It's 10 over 3 rho to the power 3 from 0 to 1. Multiplied by 2 pi. Multiplied. The integral of exponential is 1 over minus 2 e to the minus 2z from 0 to 1. And then you multiply. Upper limit, lower limit, you get 10 over 3 multiplied by 2 pi. Multiplied upper limit, you have minus 1/2
Sí, porque
minus
hay grupos
1/2
grandes, man.
e to the minus 2 minus the lower limit plus 1/2. You multiply, these are all numbers, calculator, e to the minus, your calculator, e to the minus 2, pi is 3.14. You add the number here. So this is just in case for my example, actually divergence was 0 anyway, so that's why I ended up with 0 right hand side, so flux is 0. But this is a different problem. Let divergence of A equal to something. Apply divergence theorem, find flux. Integral of divergence over volume gives you flux.
Búsquelo y comparamos.
Divergence is already given,
Porque
and then
también
dB I define
¿sabe
in
dónde?
cylindrical coordinate, and I integrate.
En termos, pero en termos valen 20.
Any question?
¿Cuántas?
And that's total flux, right?
Yes, yes.
60.
That's a good
Pero
thing
no
about
tiene
volume,
mucho
because
más.
volume integral, without breaking your integral into segments, it gives you total volume. But when you have surface integral, closed surface may be composed of several open surfaces, then you have to break integral. Find flux for each portion, and in the volume integral, do total flux. Any question? Any question? So the main application of divergence theorem, you will see later that it's part of Maxwell's equation, and actually that's what we call KVL later in electrical engineering. They're all based on divergence theorem. Okay, any question about divergence? That's all you need to know. Please just practice on one example I gave in handout and just this problem. And the previous problem and this example to get the feeling of how to handle divergence theorem. Next one is messy because it's cross product. So the next one is applying del operator to a vector. This is called curl. Okay. Curl, what's the meaning of curl? Curl is the maximum circulation of A, vector A, around the closed path. The closed path. Whatever closed. Actually, at this point, you know what? Let me put this definition aside. Just put it aside. Curl is representing circulation. Let's just put it this way. Okay. Don't worry about this one yet. Just define curl as a circulation. So I'm not saying it's wrong, but at this point, let's not worry about this. We talk about application later. Just use one word. Curling is circulation. A vector is going around, moving around. That's called curl or curling. Okay? I'll come back to this definition later. How do we define curl? Curl of A. General definition. General definition. I give you general definition, and then I give you case by case definition. General definition is 1 over H1, H2, H3. The determinant of AU1, AU2, these are vectors in the coordinate system, any one of the three coordinate systems. AU1, AU2, and AU3. Okay? And then here I put the partial derivative. du1, du2, du3. Then here I put corresponding component. So H1, AU, H2, AU2, H3, AU3. It's a cross multiplication, finding determinant of this 3 by 3. Instead of checking the formula, I can put the summarized formula, but I want to perform each integral in each coordinate system to practice, just in case. Just in case if you don't have access to formula, at least this is easy. H1, H2, H3 in front, and then H1, H2, H3, AU1, AU2, AU3, DU1, DU2, DU3, AU1, AU2, AU3. So let's go to rectangular and develop the formula for curve. For rectangular coordinate, H1 is equal to H2 is equal to H3 is equal to 1. So curve H, or curve A, sorry, is the easiest, has the easiest format. It's AX, AY, AZ, then it's DDX, DDY, DDZ, then H1, H2, H3, they're all equal to 1, AX, AY, AZ. So this is equal to, eliminating first row, first column, you have D, AZ, DY minus D, AY, DZ, AX. That's component 1. Component 2. There is a minus here, but I'm going to move the minus inside, so I'm going to have plus. However, I cross multiply DZAX first. You hopefully remember from part 1 of the course, how to cross multiply DDX minus DAZ DX A1. Or you can have minus sign here, so this switch these two and have a minus sign outside. Plus AZ, again eliminating first row, last column, then you have D AY DX minus D AX D DDY AX AZ. Okay, so this is your definition of curling or finding curve in a rectangular coordinate system. Do you have any question? I just wrote it like a regular cross product, except instead of components we have DDY. Because the format is a bit long, I have to erase for each case. Okay, now let's go to case number 2. Cylindrical. In cylindrical, H1 equal to H3 equal to 1, H2 is equal to rho. So what is curve A in cylindrical? Again, you form the matrix 1 over outside you have rho. Then you have determinant. Components, vector component, directional vectors. A rho, A phi, A z. Okay, DD rho, DD phi, DDZ. You don't have to write the general formula, you can always use this one. Then we have H1 A rho, H1 is 1, so we have A rho, H2 A phi, rho A phi, H3 AZ, AZ. Again, find determinant. So this is equal to 1 over rho, open bracket, Now you have D, A, Z, 0, I'm sorry, eliminating first row and first column, you have D, A, Z, D, phi minus D, rho, A, phi, D, Z, A, rho. Okay, D, phi, A, Z, and then you have D, D, Z of rho, A, phi, plus, again, you have 1 over rho in front of all of them. 1 over rho in front of all. Eliminating first row, first column, you have a minus, but switch. So you write D, D, Z first. It's D, D, Z, A rho, minus D, D, Z, A rho, minus D, D rho, A, Z. This is the phi component. Plus 1 over rho, again, open bracket, last column, last row. It's DD rho, DD rho of rho A phi minus DD phi, DD phi of A rho AC. By the way, this is okay. So the last row is DD rho of rho A phi minus DD phi of A rho. If you want, you can simplify furthermore to have it a bit more, I don't know, simple, like easier. So you have 1 over rho. Let's now open parentheses, 1 over rho DAZ D phi minus. Notice that this derivative is with respect to z. Rho goes out. If rho goes out, cancels this rho. So you have dA phi dz A rho plus wait for the coordinate system plus 1 over rho maybe just 1 minute, please, just one, to make sure that everything is correct. There is one thing. There is one thing I forgot to mention. Sorry, these two should match. Oh, I'm gonna go back and write my own formula. Let me put rho. I'll correct this one in a moment. The last row should be the same as the original, one of them with A, the other one with H. So this one should have rho in front. Sorry, rho cancels rho. So that's why you get the A rho, the Z minus the AZ, the rho. This row cancels this row. A phi plus. Okay, this row you cannot take it out. This row you cannot take this row out. So for this one, 1 over rho remains outside. It's d rho A phi d rho minus d A rho d phi AZ. So this is the simplified. I'll mention about this one in a moment, but do you have any question about finding the gradient? I mean, finding, sorry, determinant. Any question?
Professor, when does H2 come into play for rho?
What is H2? You don't remember
H2?
You don't remember H2 about what is H? Do you remember from first part of the course? H is length conversion. Remember when I introduced right at the beginning of chapter 3, I said anytime you want to write line increment. For line increment, we must have when we defined line increment in coordinate system. Remember, anytime you write line increment, it's dx, ax, dy, ay, dz, az. And then if you write line increment for rectangular coordinate, what was it? D rho. Then we had rho d phi. Then we had dz. What was the line increment for spherical coordinate? We had dr, r, d theta, and then we had r sine theta d phi. Any number that you put in front of d, that's length conversion. And we define h1, h2, h3. One thing I have to mention, and please, if possible, anytime I finish, we have to use all these concepts many times in future, in upcoming chapters. And the reason I go through each section, each part separately, because I want you to have maybe some collective information, some summary, create your own summary. Because even though my exam 2 is not directly related to material we covered in exam 1, but you're using the same formulas. I'm always using the same line increment, and you're always using the same surface increment. I'm always using dot product. I'm always using cross product. I'm always using the H conversion, conversion factor. This is called the length conversion factor. And I did define them when I was defining the line increment. And I did say that for rectangular coordinates, since dx, dy, dz, all three of them are length, you don't need length conversion. So h1 is equal to h3 equal to h3 is equal to 1. For cylindrical coordinate, you have d rho, which is the length, you have dz length, but for phi, you cannot put d phi, so you have to put rho d phi. I even showed on a circle, that the small portion on a circle, so you need rho d phi. Rho is your h2. And then for a spherical coordinate, again, we have two angles, so we have two h2 and h3 to convert angle to length. So the component or the coefficient we are using to convert angle to length, that's my h parameter. And I define them for each coordinate system. Any question? Okay, let me correct the formula. I gave you the general formula. Curl A is equal to 1 over h1, h2, h3, determinant. Okay, determinant, I forgot to put h, au1, h, au2, h3, au3. Then you have d, u1, d, u2, the rest is correct. And then I have h1, au1, h2, au2, h3, au3. Okay, and my previous, when I put the formula, general formula, this was okay, this was okay, this was okay. I forgot to put h1, h2, h3 in front of au1, au2, a3. Your first row is matching the last one. But rectangular coordinate doesn't make a difference, because in rectangular coordinate, h1, h2, h3 are equal to 1. In cylindrical coordinate, h1 is 1, h3 is 1, h3 is row, so that row was missing. That's why when I put for cylindrical coordinate, we have a row here. Any question? Okay, so let's write this one in a spherical coordinate. In a spherical coordinate, curl A is equal to 1 over h1 is equal to 1, h2 is equal to r, h3 is equal to r sine theta. So h1, h2, h3, you get r squared sine theta. Okay? Now, form determinant. Please pay attention, don't zoom off, because what happens if you don't understand here, then you'll remain confused with curl, and you have to use curl in upcoming chapters, following chapters. Okay, H1, AU1, H1 is 1. So you have A, R. Let me make it clear. A, R. H2 is R, A, theta. H3 is R, sine, theta, A, phi. That's your row number 1. Row number 2, DDR, DD theta, DD phi. Last row, same, except you change vector to component. AR, R, A theta, R sine theta, A phi. Determinant. Okay, now let's perform this determinant. It's equal to 1 over R squared sine theta. I need more space. Let's do it here. Okay, curl A is equal to 1 over R squared sine theta. Now, case by case. First row, first column. You get d theta of the whole thing. R sine theta A phi. d theta of R sine theta A phi minus d phi of R A theta AR plus d phi of AR. d phi of AR minus DDR of R sine theta A phi. This is A theta. Plus last one. For the last one, okay. Yeah, R theta. Sorry. I made the same mistake as my last one. Sorry. Thank you. Okay, the last one. Last one is DDR of R A theta minus DD theta of AR multiplied by R sine theta A phi. Any questions? DD of R sine theta A phi minus DD phi of R A theta, and then I had DD phi of AR minus DD R sine theta A phi times R A theta. Then I had DDR of RA theta minus DD theta of AR multiplied by R sine theta A phi. Let's simplify. So let's simplify this one. In order to simplify, I'm going to erase this part. I keep my last line. So that way I can simplify the curve. You can use like a matrix and case by case, whenever A is given, perform that gradient. Or you can write the final general formula. Okay, if I want to simplify, let's start here. This is integral over, this is a derivative with respect to theta. I cannot take theta out, but I can take R out. R cancels one R here. So, curl A. I'm going to write one by one, term by term. So I'm going to write this one as, because notice that in this case, I can move R out. For this case, I can move R out, 1 r cancels 1 r. So this is equal to 1 over r sine theta d sine theta AC d theta minus, I also took this r out, d a theta dc ar. Okay? So, what about this case? In this case, I'm integrating over r for this one. I can, by the way, 1 r in front of a theta cancels 1 r. I can also move that sine theta out because the derivative with respect to r and cancels theta. So this is equal to plus 1 r cancels 1 r, so I have 1 over r sine theta d-a-r d-phi minus, okay, this r cancels 1 r. I cannot move this r out because it's ddr, but I can cancel sine theta, so it's equal to sine theta cancels 1 sine theta, so it's 1 over r d a phi d a phi, oh sorry, I forgot r, d r a phi d r a theta. I've already canceled the r in front of a theta by one of the r's here. Okay? So that's equal to 1 over sine theta d r d phi minus 1 over r. Actually, you can also factor this 1 over r out, but it's okay. dr a phi dr a theta. This is a plus. Okay, the last one. I can move r sine theta out, canceling, I mean, this r sine theta is out, cancels r sine theta. We only have 1 r here. I cannot move this r out, so eventually for the last one, I have 1 over r left because r sine theta cancels 1 r sine theta. Then I have the r a theta dr minus dar d theta and a theta. Okay, so this is your most simplified form when you have spherical coordinate. Notice that you can always avoid writing this the simplified form, and always apply determinant case by case. So in this case, if I want to write it in most simplified form, it's equal to 1 over r. Same thing. Then I have d a phi sine theta d theta minus d a theta d phi ar plus 1 over r. I can factor 1 over r. Then I have 1 over sine theta. Actually, I can put bracket. It's nicer to use a bracket here. 1 over sine theta dar d phi minus dr a phi dr a theta plus 1 over r d r a theta dr minus dar d theta a phi. such a long format, but in many practical applications, you don't have many of them. This is just a derivative. This is the most simplified. I mean, this is the most simplified form. So when they give you a vector and ask you to find the curl, you have to go through each step. It's a tedious process. Fortunately for electrical engineering, for most part, you will see the way that we use this curling regarding wire or curling regarding electromagnetic field. Usually in a spherical coordinate, you have a perfect symmetrical arrangement, and you only have, for example, AR component. Many times when they give you problem, many of these components are zero. You may have only AR component, you may have only a phi component. So you can either use that general determinant formula case by case, or you can use this formula in order to find curl. What is the application of curl? Before we talk about application, let me quickly mention about some properties, and then I'll continue with application next time. Properties, you have it in my handout, but just a list of properties. Anytime you apply a curl to summation, you can move. So this is equal to curl A plus curl B. We can move it. Okay, curl of a curl, like if you have curl of a cross product. Okay, this is important because you have a very important law in electrical engineering, electromagnetic later. It's kind of weird looking expansion. This is not easy, this is messy. It's a cross product and a cross product. It's a B minus B times divergence A plus B divergence, plus B dot A minus A dot B. Surprisingly, in one of the exam they gave A, B, and they asked, they had this in mind, like this is a part that we have to practice. And then I'm going to discuss this one, I'll show you next time. But I give you two more examples, and I'm going to practice on properties and also application of curl. Do you have any question? I want to finish at this point, but do you have any question? One thing I want to draw your attention, you may say, this is how do I see this as a shortcut, because I have a long expression here. Notice taking divergence is easy in any coordinate system. Taking gradient is easy. Dot product is easier than cross product. If you don't want to use this formula, you have to find a cross product of two vectors. You get a messier vector. Then you have to apply the cross product with del operator. Usually this is more difficult, even though this one is a longer expression. Do you have any question? If you don't, I'll stop here and I'll continue next time. I didn't take roll today. Any question today?
Examples on Wednesday, right?
Sorry?
We will start these examples on Wednesday?
Yes. Any question? There are for curl. Again, examples, I cannot make too many examples because the process is kind of messy, but there are a few examples I show in class. And I cannot assign homework yet because I want to finish the curl and Stokes theorem and then apply homework problems so you can practice. Or I can assign homework problem with later due date, gradually so you can solve some of the divergence parts. Yeah, I'm going to assign homework problem today or tomorrow. You can start with the divergence and as I finish each part, then you can continue with your homework. Any question? Okay, thank you. Have a good afternoon.
Thanks, Professor.
Thanks.
Yeah,